Hello dear students, here we are going to discuss the Aldehydes Ketones and Carboxylic Acid 100 MCQs. Now we are discussing the 100 MCQ as 4 parts. First part contain 25 questions, like 4 parts we have. So after completing overall the MCQs, you will get a clear idea about which all questions, which all area you have to be concentrate more in this chapter. Remember, it's a lengthiest chapter, more important chapter. Okay. Let's go to question number 1. Here is the question number 1 for you. Study the following sequence of reaction and identify compound X and Y. Study the reactions first, okay, then you attend this session. Say, first one, you can see toluene is given here, right? Toluene. Toluene react with the chlorine and light. Where is this reaction we studied? Side chain chlorination. So whenever you add chlorine, when you add chlorine to toluene, it becomes benzene with a CHCl2. That is called benzyl chloride. So compound X is benzyl chloride. Where is benzyl chloride? Yes, this one, benzyl chloride. Benzyl chloride on hydrolysis, these two H2, this 2 Cl cut it becomes CHO. That is benzaldehyde, right? Benzaldehyde. Yes, this one. Option D is the answer. So what is this reaction? Toluene, when react with the chlorine in presence of light, it will give you benzyl chloride. That's on hydrolysis, you will get benzaldehyde. It's a preparation of benzaldehyde from which one? Toluene. So benzyl chloride is this one, benzaldehyde is the final product. Next one, arrange the following compound in increasing order of their reactivity in nucleophilic addition reaction. We discussed in class, nucleophilic addition reaction is carried by aldehydes more than ketones. Aldehydes will undergo more nucleophilic addition than ketone because aldehyde contain less bulky groups. So let us see butanone. What is butanone? 4 carbon with a ketone. Okay. Next one is propanone. Okay, propanone means 3 carbon with a ketone. Propanol. Okay, it's an aldehyde. And ethanol. What is that? What is ethanol? 2 carbon with aldehyde. Ready. If you consider this is ABCD, you know aldehydes are more reactive than ketone towards nucleophilic addition. So among these 2 aldehyde, which one? This one. Where less bulky group, where is less carbon present, then more nucleophile can attack. More attack of nucleophile. So D, ethanol is the highest, then propanol. Where is that? Ethanol and propanol. That is only option A. Next what? Propanone, then butanone, because propanone contain 2 methyl group, but here it contain methyl and ethyl group. So remember, more bulky group when it comes, nucleophile cannot attack this carbon, right? So we discussed that aldehydes are more reactive than ketone toward nucleophilic addition. So aldehydes are more, where aldehyde contain less bulky group, where more reaction happen. Keep in mind. So ethanol, propanol, propanone, butanone, option A itself, that's a correct answer. Next, find the product of the following reaction. What is this reaction? See all of you, it's our acetophenone, right? Benzene with the COCH3, what we call acetophenone. When a ketone react with the amine, all of you, we studied amine and ammonia derivatives, right? We discussed hydrazine, phenylhydrazine, which one, semi-carbazide, many things. So these is also contain ketone and an amine. If it amine come, take this H2 and take this O. Means basically water you remove. Just to join. What is left? Benzene with CH3 double bond connected here. N, it's connected to CH2, CH3. Where is this compound? All of you just check it. C on which one? CH3 and double bond and CH2, CH3. That's option which one? B is the correct answer. So whenever a aldehyde or ketone react with the amine derivative, how can we understand amine derivative? They contain NH2 group. So just to take the oxygen from our compound and H2 from the amine and just to join them. That's it. Very simple. So this is the compound. And one more thing, remember all of you, that may not be discussed in theory part. Aldehydes when react with, aldehydes carbonyl compound when react with the amines. These are called what? Amines. The product is called what? Schiff's base. What we call Schiff's base. When carbonyl compound react with the amines, these are called what? NH2 group, what we call amines, and the product is called what? The addition product, what we call Schiff's base. Okay, keep in mind. We'll discuss in one another question in detail. So here is the product. Next one, addition of water to alkyne occur in acidic medium and in the presence of mercury 2 plus ion as a catalyst. Yes, we studied. To an alkyne when we add water in presence of HgSO4 and H2SO4, we get enol first. That undergo tautomerism. Sometime we will get aldehyde, sometime we will get ketones. Correct. Question, which of the following products will be formed on addition of water to but1-ine? Let's try. What is but1-ine? CH3, CH2, C triple bond CH. This is but1-ine, to which they are going to add what? H2O. You know, H2O contain the ion H plus and OH minus. So we can follow Marconico's rule here. So negative part goes to carbon with less hydrogen. Positive part goes to carbon with more hydrogen. You will get the product as CH3, CH2, COH, double bond CH2. Right? And this product, you know, it contain ene and ol. It contain alkene and alcohol together. So what we call it as enol. And it will undergo tautomerism. It will undergo tautomerism. What is tautomerism? The alcohol hydrogen shift to this carbon. Means this hydrogen reached here. So what is the product? CH3, CH2, C double bond O, CH3. You are getting butanol. So where is butanol? Where is this product, my dear? That is option 2. CH3, CH2, C double bond O, CH3. Okay. So to an alkyne, when you add water, it follow, if it is unsymmetrical alkyne or alkene, it follow Marconico's rule. It is happen in presence of what? Mercuric sulfate and H2SO4. Okay. So to an alkyne, when you add water in presence of this catalyst, you will get enol first. That undergo tautomerism will give you what? Aldehydes or ketone. Here it is a ketone. Next one. Which of the following compound is most, this is a repeated question for exam, my dear. Which will undergo most reactive toward nucleophilic addition, reaction with the HCN. These all are nucleophilic addition. Remember, aldehydes are more reactive than ketone toward nucleophilic addition because aldehyde contain less bulky group. Okay, so which of the following compound is most reactive toward? Most reactive means check aldehyde is there or not first. Yeah, this is an aldehyde, this is an aldehyde, this is a ketone, this is a ketone. Because ketone, both side bulky group will be there. Nucleophile can't attack. So among this aldehyde, which one is the least size or the less bulky group? Of course, this one, right? So option A. Here phenyl, big bulky group, so nucleophile cannot attack. So it should be, if it want to be most reactive, it should be an aldehyde and less bulky group. So most reactive is option A. Next one. What is the correct order increasing acidic strength? Okay, acidity they are asking. We studied acidity mainly depends on the presence of withdrawing group and donating group. Withdrawing group will increase the acidity. Remember, what is, okay, first compound is given as phenol, right? Phenol. And next one is given what? Ethanol, CH3, CH2OH. Next one is chloroacetic acid. Chloroacetic acid, okay, acetic acid with chlorine. And what? Normal acetic acid, CH3COH, okay. We know, my dear, carboxylic acids are more acidic than alcohol, no doubt. Carboxylic acid more acidic. So, see, this one is more acidic. Among this one, this is more acidic because chlorine, there is an electron withdrawing group. Electron withdrawing group is there, it make more acidity. So, this is the most acidic one. Where is chloroacetic acid, the highest one? Chloroacetic acid, then acetic acid. That is option 3. Okay, 3 is actually I am writing here. This is option 3. So, chloroacetic acid, then acetic acid. Next, among these two alcohol, which one we already studied in alcohol chapter, phenol is more acidic than normal aliphatic alcohols, right? Because it gives phenoxide ion. So, option 3 is the correct answer. Keep in mind all of you. Point is, carboxylic acids are more acidic than alcohols. Where more electron withdrawing group present, it will be more acidic in nature. Right, next. The reagent which does not react with both acetone and benzaldehyde. Acetone is basically what? Acetone is a ketone, benzaldehyde is an aldehyde. So which reagent do not react both aldehyde and ketone? Which one can you say? We studied sodium hydrogen sulfide, NaHSO3, and phenyl hydrazine, okay, filling solution, okay, then Grignard reagent. Can you say we studied a sodium hydrogen sulfide to react with both aldehydes and ketone. Phenyl hydrazine, yes, react with both aldehydes and ketone. Filling solution. Filling solution is only, filling test is only given by aliphatic aldehyde. It won't give by ketone. So, Fillings reagent is only react with aldehyde, not with the ketone. Grignard reagent, yes, it react with both aldehydes and ketone, give you alcohols. Cannizzaro reaction is not given by, in order to give Cannizzaro reaction, there is no alpha hydrogen, that is a condition. Yes or no? In order to give Cannizzaro reaction, no alpha hydrogen. Here they are asking which Cannizzaro reaction not given by, which means they contain a alpha hydrogen. Which one contain alpha hydrogen? Option 4. Because this is the aldehyde. Aldehyde main functional group connected carbon is called alpha carbon. Alpha carbon contain hydrogen is called alpha hydrogen. Yes, it contain alpha hydrogen, so it won't give Cannizzaro. What about this one? This is the aldehyde group. So this is the alpha carbon. See, no alpha hydrogen. See, this is the main functional group. So this is alpha carbon. See, there is no alpha means alpha hydrogen. Here no alpha hydrogen. So main functional group is aldehyde. Aldehyde connected carbon is called alpha carbon. And alpha carbon containing hydrogens are called what? Alpha hydrogen. So Cannizzaro reaction not given means they contain alpha hydrogen. That is option 4. Which product is formed when the compound benzaldehyde is treated with a concentrated aqueous KOH? What is benzaldehyde? Benzaldehyde, benzene with the CHO. Benzaldehyde react with which one? Concentrated KOH. Can you identify which reaction is this, my dear? We discussed in class. This is called our Cannizzaro reaction. Because Cannizzaro reaction, the compound do not contain alpha hydrogen. Yes, benzaldehyde, no alpha hydrogen, and base is concentrated. We know what happened. Cannizzaro reaction means the reaction between two same species, right? So let me take one benzaldehyde plus one another benzaldehyde. How to write the product in Cannizzaro? One compound, write it as its alcohol. So benzaldehyde will become benzyl alcohol plus the other compound, write it as which is base is using here K, right? So the second compound, write it as the corresponding potassium salt of acid. So we can write it as what? Cook, right? So where is this? Where is this? COOK and CH2OH? That is option 2 is the answer. So how to write Cannizzaro? How you understand that it's Cannizzaro? Base is concentrated and the compound do not contain alpha hydrogen. So we can treat one compound, convert into its corresponding alcohol, which means CHO, make it CH2OH. The other one becomes CHO, becomes acid actually, COO, but potassium or sodium is there, that will replace the hydrogen. So you will get cook or COONA if it is NaOH. So answer is which one? That is the same example we discussed in Cannizzaro as an example, study all of you. So the answer is this option 2. Next one. Structure of A and type of isomerism in the above reaction are respectively. Structure of A. Okay, let us check it. What is this reaction, my dear? It is an alkyne to which they are adding mercuric sulfate. So it's an addition of water. So let's try. So the compound is CH3C triple bond CH, to which when you add water in presence of mercuric sulfate and H2SO4, H2O contain H plus and OH minus. It follow Marconi-Kos rule. So H here, you will get CH3, COH, double bond CH2. We will get a compound called enol. It will undergo tautomerism. They said which isomerism, right? We know enol undergo which isomerism? Enol undergo tautomerism. And what happened? This hydrogen reached here. You will get CH3, COCH3. You will get propanone. Yes, ready. So question. Structure of A. What is the structure of A, my dear? What is the name of this compound A? Alkene is there, alcohol is there. Let me put 1, 2, 3 here. So 2, we can say that total 3 carbon, right? Proper first position alkene. So proper 1 in and second position alcohol. That's IUPAC name. So proper 1 in, 2 ol, and the isomerism is what? Tautomerism. So proper 1N2-ol. Option 4 correct, my dear. Okay, proper 1N. Yeah, proper double bond is there. Alcohol is the main priority group. So I am starting from here. 1, 2, 3. Total 3 carbon. Therefore proper. First position alkene, second position alcohol. Proper 1N2-ol. And what is the isomerism? That is tautomerism. Ready. Next one. Compound A and C in the following reactions are. So let me take the first compound. What is the first compound? CH3CHO, ethanol. What happened? Ethanol react with the methyl magnesium bromide along with the H2O. I am writing product directly, my dear. How to write the product directly? To an aldehyde, when you add Grignard reagent followed by hydrolysis, very simple. Take the alkyl group from the Grignard reagent, put it on this carbon. And finally, the O become OH. Okay, the O become OH. Finish. So both of the steps I am doing together. So I will get CH3, CH. Now the new CH3. Okay, and now this O becomes what? OH. This is what happened after this step. So this is the compound A. This compound A, they are heating with the H2SO4. You know H2SO4, when you are heating with an alcohol, it undergo dehydration. What is dehydration? OH take from alpha, hydrogen take from beta, put a double bond here. You will get propene. Right? We will get propene. Okay. This is your compound B. Now propene when undergo hydroboration, oxidation, we studied in alcohol chapter where propene become what? Propanol, right? Propene become what? Propanol, CH3CH2OH. So what is this compound, my dear? This is propan-2-ol, right? This is compound A is propan-2-ol and compound C is which one? Propan-1-ol, right? Propan-1-ol. So question, compound A and C show which isomerism? See, propan-2-ol and propan-1-ol shows which isomerism? That calls what? Position isomerism, right? Positional. See, propan-2-ol and propan-1-ol, their position of the alcohol group is different. So it will show which one? Positional isomerism. Okay, clear? Which is the most suitable reagent for the following conversion? Analyze the reaction. There is nothing happened to the double bond, right? Nothing happened to the double bond, but here ketone converted to what? Carboxylic acid. Ketone converted to carboxylic acid. So it should be a what? A strong oxidizing agent. Tolerance reagent, it react only with aldehyde, so it is not possible. Benzoyl peroxide no needed. Peroxide effect is no needed here. I2 with the NaOHN solution. Yes, I will go with the 3. What is this I2 and NaOH? That is our iodoform test. Iodoform test. What is iodoform test? Let me tell you. CH3, CH double bond, CH single bond, CH2, CO, CH3, right? Iodoform test means, we discussed that in order to give iodoform test, it should contain CH3CO group. Yes, it is there. So let me react with the I2 and NaOHN once you heated. We discussed detail in our class. During iodoform test, you will get total 4 products where 3 of them are always common. What are the 3 common? Iodoform, NaI and H2O. One is different. They're asking here. See, among the CH3CO group, this carbon becomes CHI3. So what is left? The left overall become a acid. Left part or remaining all becomes an acid. So it becomes CH2COO. And if it is sodium is there, okay, sodium salts will be there. Basically, it becomes a carboxylic acid. That's what they given there. So this is our iodoform test, my dear. So in the how to write iodoform product is very simple. Among the COCH3, the CH3 part becomes CHI3. Remaining the entire part, write it as the acid. That's it. If sodium is there, sodium replace the hydrogen. That's it. Okay. Next one. Which of the following compound will give butanone on oxidation with the alkaline KMnO4 solution? We know butanone is a ketone. If you want ketone by oxidation, it should be a secondary alcohol. Secondary alcohol on oxidation, we will get a ketone. Butanol is a primary alcohol. Butan-2-ol is a secondary alcohol. Yes. Check it all. Is it butan-2-ol? Yes. Butan-2-ol on oxidation. What happened? Oxidation means removal of hydrogen. It becomes what? Butan-2-on. Right. So remember, this is the point. Secondary alcohol on oxidation, you will get ketone. You know, alkaline KMnO4 is an oxidizing agent. Ready? In Clemmensen reduction, what is Clemmensen reduction? Aldehydes or ketone react with a zinc amalgam and HCl. We'll get hydrocarbon. In Clemmensen reduction, carbonyl compound is treated with what? Zinc amalgam and HCl. Zinc amalgam and HCl. You know, we are using what? Zinc, ZnHg, right? Zinc amalgam, right? We are using zinc amalgam and HCl is the reagent. Okay, next. When acetaldehyde, what is acetaldehyde? Acetaldehyde is CH3CHO. Ethanol is also called acetaldehyde. Acetaldehyde is heated with a failing solution. What is failing solution overall? You know, CuO, copper oxide. You know, along with a base, when you heat it, you know, aldehyde become carboxylic acid. And what happened to CuO? CuO become Cu2O, cuprous oxide, reddish brown color. So the question, when acetaldehyde treated with a filling solution, it gives a red precipitate of what? Cu2O, cuprous oxide. Oxidation of cyclohexene. What is cyclohexene? This is what we call cyclohexene, right? Cyclohexene. Using acidified KMnO4. Dear all, KMnO4 is a very strong oxidizing agent. So whenever we are treating an alkene with the KMnO4, this is the way. Break the double bond. See, this both of these carbon become carboxylic acid. So C, what is this? C becomes COOH. And what is this? CH2. Next is CH2. Here also CH2. Here also CH2. Here is COOH. Right? This compound is called adipic acid. Remember all of you? Adipic acid. Short form, let me write. One acid in between 4 CH2 group. This is called what? Adipic acid. 2 carboxylic acid, middle CH2 4 time is called what? Adipic acid. So remember, cyclohexene on strong oxidation, double bond break, you will get 2 carboxylic acid. That product is called adipic acid. Option A is the answer. Next, which of the following order of relative strength of acid is correct? Which order of acidity is correct? My dear, analyze the compound. Here one is given chlorine, one is given fluorine, one is given bromine. You know, they are withdrawing group. Halogens are withdrawing group. Which is the most stronger withdrawing group where more acidity? Which is the most strong withdrawing group? Fluorine, then chlorine, then bromine. So we can say fluorine 1 is greatest, then chlorine, then bromine. So that's option D. Which is the most suitable reagent for this conversion? What is this conversion, my dear? That's already we discussed the same question. Here you see double bond, nothing happened. The ketone becomes carboxylic acid. That should be our iodoform test. Where is iodoform? I2 and NaOH solution. Okay. So the same one question we discussed. The formation of cyanohydrin from a ketone is an example of. What is that? When a aldehyde or ketone treated with a hydrogen cyanide, the product what we call it as cyanohydrin. We discussed under which topic? Hydrogen cyanide addition is called which one? Nucleophilic addition reaction. Nucleophilic addition reaction. Okay, remember, addition of hydrogen cyanide is a nucleophilic addition reaction. Next, which aldehyde will give Cannizzaro reaction? If it want to give Cannizzaro reaction, alpha hydrogen should not be there. So see this aldehyde connected carbon is alpha. Yes, it contains alpha hydrogen. So it cannot give. This is the aldehyde and this is actually CH2. Okay. This aldehyde, yeah, this already alpha hydrogen is there. Check it. Option C is our answer. What is option C? C connected to 3CH3 group, right? C connected to 3CH3 group. Okay. And it contains which one? CHO. Yes. Check it all. Here aldehyde is the main group. Main group connected carbon is called what? Alpha. Alpha carbon contain hydrogen, what we call alpha hydrogen. Yes, see, there is no alpha hydrogen. So it can give what? Cannizzaro reaction. Option C is the correct answer. Carboxylic acids are more acidic than phenol and alcohol because, you know, let me take a carboxylic acid, for example, benzoic acid, and let me take a phenol. Why carboxylic acids are more acidic always than phenol? You know, when carboxylic acid lose H plus ion, we are getting carboxylate ion. When phenol lose H plus ion, we are getting phenoxide ion. This carboxylate ion is more stable than phenoxide ion. Because here, when you're drawing the resonance structure of this one, the oxygen carry negative charge. That is more favorable. Remember, carboxylic acid when lose hydrogen, you will get carboxylate ion. Phenol when lose hydrogen, you will get phenoxide ion. Where carboxylate ion is more stable than phenoxide ion. So, carboxylic acids are ready to lose H plus ion. So, therefore, the main answer we can call it as option C, resonance stabilization of their conjugate base. What do you mean by conjugate base? When this one lose this H plus, remaining compound what we call the conjugate base, it is highly stable due to resonance. Therefore, carboxylic acids are more acidic than phenol. Propionic acid with the bromine. What is propionic acid? CH3, CH2, COOH, right? Propionic acid react with the bromine in presence of red phosphorus. Can you identify which reaction is this? This is our HVZ reaction, Hell-Volhard-Zelinsky reaction. You know where this bromine get added, right? You know, we have to remove one alpha hydrogen, put bromine on this place. But they were asking you a dibromo product. Dibromo means you have to remove 2 hydrogen and put 2 bromine. So, always in HVZ reaction, you should remove alpha hydrogen. You know, this is alpha carbon. So, these 2 are alpha hydrogen. Remove these 2 alpha hydrogen, put 2 Br there. So, you will get CH3, C, Br, and then we have what? COOH. This is the product. Where is this? Where is this? That is option D. CH3, C, yes, C, Br2 and COH. Okay. So, whenever there is a carboxylic acid which contain alpha hydrogen, react with the bromine or chlorine with the red phosphorus, you will get what? Alpha position halogen comes by removing hydrogen. Here they need dibromo. Dibromo means you have to take 2 hydrogen and put 2 Br. Clear? Next one. The reaction in which hydrocarbons are formed when aldehydes and ketone are reduced with the amalgamated zinc. Zinc amalgam means which reaction? Clemmensen reduction and HCl. Clemmensen reduction, right? Clemmensen reduction. Zinc amalgam means Clemmensen reduction. Next up. Which of the following method cannot produce aldehyde? Cannot produce aldehyde. Many methods we studied preparation of aldehyde. Oxidation of primary. Yes, primary alcohol on oxidation we get aldehyde. Dehydrogenation. What do you mean by dehydrogenation? Removal of hydrogen, or also you can call it as oxidation. So dehydrogenation means oxidation, okay, because dehydrogenation means removal of oxygen. Removal of oxygen is called oxidation. Oxidation of secondary alcohol, no. So oxidation of primary alcohol give you aldehyde. Oxidation of secondary alcohol give you what? Ketone. This is not a method. So option B. Yes, alkenes on ozonolysis we get aldehyde. Hydration of ethine, yes, also that we will get. So, secondary alcohol on oxidation, you will get ketone, not aldehyde. So, B is not a method. 25. Which of the following reaction can produce ketone? Can produce a ketone? That same question. Oxidation of primary alcohol give you aldehyde, no ketone. Dehydrogenation means what? Oxidation. Oxidation of primary. They see, they're making confusion. Oxidation and dehydrogenation meaning same, okay. Dehydrogenation of tertiary alcohol, no. Oxidation of secondary alcohol, yes. Oxidation of secondary alcohol give you what? Ketone. Question number 26. Conversion of propyne to acetone require 3 important reagents. Identify which of the following is not one of the 3. What is this reaction actually? Propyne. Propyne is this one. Alkyne to a ketone they were asking. Alkyne to ketone. Yeah, that is our addition of water in presence of mercuric sulfate and H2SO4. You know, first Markovnikov's addition, then you will get enol, then it undergo tautomerism, you will get aldehyde or ketone. So they were asking, so which all reagents you need in this reaction? Water you needed, mercuric sulfate, sulfuric acid, everything you needed except which one? Zinc dust. So they are basically asking whether you know the reaction completely or not. Okay. Next. What is the catalyst used in the hydrogenation of acetyl chloride to produce ethanol? What is acetyl chloride? Acetyl chloride is CH3COCl. Ethanoyl chloride is also called acetyl chloride. This acetyl chloride, if you want to convert it into ethanol, which reagent we are using? My dear, can you tell me which reaction is this? This is our Rosenmund reduction, first name reaction. Acid chloride, when react with a hydrogen in presence of palladium and barium sulfate, one HCl go, you will get CHO. Preparation of aldehyde from acid chloride by addition of hydrogen and palladium and barium sulfate. Palladium over barium sulfate. Palladium over barium sulfate is called what? Rosenmund reduction. Okay, palladium and barium sulfate. Which of the following carbonyl compound can be prepared from Rosenmund reduction? Same question. Which one you can prepare? Which one carbonyl compound can be prepared? Okay. Methanol, acetone. You know, ketones cannot prepare by Rosenmund. Rosenmund is used to prepare aldehydes. Methanol. What is methanol? Methanol is not possible, my dear. At least one carbon should be here. Benzaldehyde is possible. Let me take you benzoyl chloride. Benzoyl. This is benzoyl chloride. When you react with the hydrogen in presence of palladium and barium sulfate, what happened? One HCl go, one H come to the side. Yes, you will get benzaldehyde, my dear. So option D is possible. Option D is only possible. Which of the following is required in Stephen reaction? What is Stephen reaction? Cyanide, when you treated with a stannous chloride, right? What is stannous chloride? SnCl2 along with HCl. First you will get imine. Imine on hydrolysis you will get what? Aldehydes. So which of the following is required? That is our stannous chloride SnCl2 is what required. That's called Stephen reaction. Next one. Which of the following compound helps in reducing ester to aldehyde? My dear, under Stephen reaction we studied one topic. If you want to convert a cyanide into aldehyde, we have an alternate reagent other than Stephen reaction, that is called dibal H. Can anyone say, can anyone remember what is the full form of dibal H? Diisobutyl aluminium hydride. This reagent we are using to convert cyanide to aldehyde. Even a ester also you can convert it to aldehyde by dibal H. So, in order to convert an ester into aldehyde, what we can use? Dibal H. I think that is the only one compound we know from this one, right? Okay, dibal H. Identify X in the following reaction. What identify X in the following reaction? Can you identify which reaction is this? See, toluene converted to benzaldehyde. Three methods we studied. One is Itard reaction. One is treating with which one? CrO3. And one is with a side chain chlorination. Which reaction is this? With a carbon disulfide and all. This is our Itard reaction. This is our Itard reaction. Remember, toluene first treated with a CrO2Cl2 along with the CS2. That is called what? Chromyl chloride. Where is CrO2Cl2? This one. This is our Itard reaction. If you remember, this is under the theory you can say, toluene when react with the chromyl chloride CrO2Cl2 along with the CS2, first you will get a chromium complex, right? A big chromium complex. That's on hydrolysis you will get benzaldehyde. So the compound is chromyl chloride. Acetyl chloride, again. What is acetyl chloride? CH3COCl. Acetyl chloride react with something to give butan 2-on. What is that? Butan 2-on. Okay, what is butan 2-on? This is butan 2-on. Check it all. This is a acid chloride, right? From acid chloride, how we prepared a ketone? Can you remember the method of preparation? Acid chloride, how to convert into ketone? We studied by treated with a dialkyl cadmium. Dialkyl cadmium. When acid chloride react with the dialkyl cadmium, we can get ketone. So where is that? Which one? Okay, I will go with. Okay, see this part already there in this one. So eth is needed. So eth is we needed extra. So let me go with the diethyl cadmium. What is diethyl cadmium? C2H5 twice CD. What is this process? Very simple. CD go with the Cl as CdCl2. So CH3CO will combine with the C2H5. Yes, that's a product. Remember, If you want to prepare a ketone from an acid chloride, react with a dialkyl cadmium. Okay, so diethyl cadmium. What is formed after the hydrolysis of the product of the reaction between benzonitrile? What is benzonitrile? Benzonitrile means this one. Let me write here. Benzonitrile means benzene with a cyanide. This is called benzonitrile, and a methyl magnesium bromide, CH3 MgBr, Grignard reagent. You know, Grignard reagent, when react with the cyanide, the product is a ketone. So how the mechanism we discussed in class, the alkyl group attack on carbon and N become N minus. So we will get benzene with the C double bond N, to the C already attacks CH3, N become N minus, to the N minus this Mg plus Br will attack. Finally, very simple, H2O while you adding, you know, just remember simple, cut the C double bond, put this oxygen on carbon, H2 on nitrogen. So you will get benzene with the what? C double bond OCH3. What is benzene with the COCH3? We call acetophenone. What is the product called? Acetophenone. Yes, option B. So remember all, cyanide when react with the Grignard reagent, we will get a adduct. That's on hydrolysis, you will get a ketone. Okay, next one. Friedel-Crafts benzoylation of benzene give. What is benzoylation mean? Benzene treat with a benzoyl chloride. Benzene treat with what? What is this? Benzene. What is this? Benzoyl chloride. What is Friedel-Crafts acylation? Means anhydrous AlCl3. What happened? This group come to our benzene ring. You will get benzene with the CO and one more benzene ring. This is called what? Benzophenone. What is called? Benzophenone. So, benzene when undergo reaction with the benzoyl chloride, it like same like our Friedel-Crafts acylation. This is called benzoylation, and you will get benzophenone. 35. Identify the reagent for the conversion of but2ene to ethanol. See, but2ene is what? An alkene. Alkene to aldehyde. Alkene to aldehyde is ozonolysis. What is ozonolysis? Adding ozone, then zinc and water. Option A. Finish. See the conversion. Alkene, if you want to convert into aldehyde or ketone, reaction is ozonolysis. Next. Which of the following reaction does not give benzaldehyde? Does not give benzaldehyde. Rosenmund reaction, yes, it can give, already discussed. Itard reaction, yes, that purposefully to make benzaldehyde. Getterman-Koch reaction, yes, that is to benzene to benzaldehyde. Friedel-Crafts acylation, no. Friedel-Crafts acylation will give you mostly ketones. Friedel-Crafts acylation cannot give benzaldehyde. Ester is formed by a reaction between what? Here all esterification. Ester is formed by the combination of one acid and one alcohol. One acid and an alcohol. Ester is formed by a reaction between acid and alcohol. Aldehydes and ketone undergoes dash reaction. Both aldehydes and ketone can undergo what? Nucleophilic addition reaction. That's only we discussed in classes. Nucleophilic addition reaction, right? Because both of them contain which group? Carbonyl group. So nucleophile can easily attack here. Next. What is the correct order of the reactivity of the following toward nucleophilic addition? Again, what is methanol? Methanol is HCHO. What is ethanol? Ethanol is CH3CHO. What is acetone? Acetone is CH3COCH3. That is what acetone. So my dear, if you consider that A, B, C, we know aldehydes are more reactive toward nucleophilic addition. And where aldehyde, where less bulky group, where more reaction. So here you see small group, here you see bulky group. So A is more reactive, then B, and then ketone. So let's go with option A itself. Methanol, ethanol, and acetone. Ready. What is the correct order of the reactivity? Again. See, benzaldehyde. What is benzaldehyde? Benzene with the CHO. Benzophenone. What is benzophenone? Benzophenone means benzene with the CO and one more benzene ring. Benzophenone. What is acetophenone? Acetophenone is benzene with COCH3 is called acetophenone. Ready, my dear. You know, aldehydes are more reactive. So this is aldehyde. So it's more reactive. These are ketone. Among these two ketone, which is more reactive, I will go with this because it's small bulky and less big bulky group. Here both are big bulky groups. So first one benzaldehyde, then acetophenone, then benzophenone. So benzaldehyde, acetophenone, benzophenone, that is option D can be tried. Which of the following is the most reactive toward hydrogen cyanide, HCN? My dear, where we studied hydrogen cyanide addition, that is also nucleophilic addition. Indirectly they are asking you. So which will undergo HCN addition faster and all means they are asking you which will undergo nucleophilic addition faster. So most reactive, right? So acetophenone, I am just writing. Let me just do one thing. Ketone you cut first. Acetophenone is a ketone. That's all. Okay. Remaining are benzaldehyde. What? Okay. Benzaldehyde is there. Next para-nitrobenzaldehyde is there. Para-nitro. Next para-tolualdehyde. What is meant by tolualdehyde? Aldehyde with the toluene. Okay. Here you see all are aldehyde. Only what is the difference? You have a electron withdrawing group, right? You know, nitro group is a electron withdrawing group. Alkyl groups are electron donating group, which will increase the nucleophilic addition. Remember all of you, withdrawing group. Because if there is a withdrawing group, they will withdraw the electron, make this carbon more positive. So nucleophile can attack easier. So remember, electron withdrawing group increase the nucleophilic addition faster. So I will go with the para-nitrobenzaldehyde. Now the hydrolysis of the addition product of acetone and methyl magnesium. What is acetone? CH3COCH3. Okay. Acetone, they are addition with the what? Methyl magnesium iodide. Hydrolysis of the product formed by this. So secondly, they are hydrolyzing. What is this? I told you how to write the product in detail. This is Grignard reagent. Grignard reagent contain Mg plus and alkyl minus. This alkyl definitely attack on this carbon. Finally, the O become OH. Finish. Okay. So the alkyl group from the Grignard reagent put it on this carbon and O finally make it OH. Finish. So what is the product? CH3, COH and then CH3 and one more CH3. What is this compound is called? What is this compound is called? This is called, what is this group? Tert-butyl. So this compound is called what? Tert-butyl alcohol. Okay. Option C, tert-butyl alcohol. The following is an addition product of the reaction between dash and sodium bisulfite. What is sodium bisulfite? That is our NaHSO3 addition. If you want to get this one, CH3CH, this is the contribution from our compound. These are getting through the reaction. So let me tell you one thing. Let me try this one. Okay, CH3COH. What is this aldehyde? Ethanol. Because I took this CH3 and H. This is the main part, the aldehyde or ketone. So CH3COH when react with the NaHSO3. Okay, let me write it for understanding. I'm writing this compound as CH3COH. What is this aldehyde? Ethanol. Plus sodium hydrogen sulfide, that's a sodium bisulfite. Let me add. You know, sodium bisulfite contain Na plus and HSO3. So HSO3 will attack on this carbon, O become O minus. To the O minus, this Na will attack. You will get CH3, CH and O becomes what? ONA. You know, HSO3 directly, please don't write. HSO3, how you should write? OSO2H, because from HSO3, oxygen is the one making bond. Okay. And what happened? The sodium and hydrogen ions can switch it. You will get CH3, CH and OH and OSO2Na. Yeah. So, if you want to get this product, you just analyze about this part. Yes, CH3CH. So, that is getting from which aldehyde? Ethanol. So, where is ethanol? Ethanol is what? Acetaldehyde. So, when acetaldehyde react with the sodium hydrogen sulfite or sodium bisulfite, you will get this product. Now, the following acetal, we studied now what is acetal. What is acetal? When an aldehyde react with the alcohol, we get acetal, hemiacetal first. Again, when it react with the one more alcohol, you will get acetal. So, the following acetal shown is formed by the reaction between dash and dash in the presence of dry HCl. My dear, so you analyze about this compound. That's again very clear. What is this compound? Ethanol. Okay. So this compound is what? Ethanol. So let me write the product here. CH3COH, that is ethanol. This one, let me react with, this is the alcohol. So 2 carbon is coming means the ethanol they are adding. What is ethanol? CH3CH2OH. You know very well, in CH3, in alcohol, what is the ions you have? You have the ions like, we can write it as, if you're writing ROH, you know, R plus and OH minus, right? Similarly, you have CH3, CH2 plus and OH minus. So, OH is the nucleophile. They will attack on carbon, O become O minus. To the O minus, CH2, CH3 will attack. So, you will get CH3, CH, then who is attacking here? OH, then who is coming to this side, to this one, you are getting OCH2, CH3. Okay. This is called hemiacetal. This again, when you treat it with the one more alcohol, CH3, CH2, OH, one OH and H water you cut, you will get CH3, CH, then O, CH2, CH3. Again, here O, CH2, CH3, we will get it. It's a reversible reaction. And this is called hemiacetal, and this product is called what? Acetal. So, question, what we need to treat it? That's no doubt ethanol, not ethanol and ethanol. What can we write? Yeah. First compound is, this is ethanol, to which what you are adding? Ethanol, right? Ethanol and ethanol, right? Ethanol and ethanol. So, the following acetal is shown by the formation reaction between ethanol and ethanol. Yes, you will get this product. So, where we studied this all reaction under nucleophilic addition. Okay, my dear student, listen carefully. Next one, acetone. What is acetone? Acetone is nothing but propanol. Acetone react with the ethylene glycol. What is ethylene glycol? Let me write acetone in another way. CH3, CO, CH3. This is called what? Acetone. What is ethylene glycol? OH, CH2, CH2, OH. Hope you remember. It's undergo a cyclic formation. This H2O we cut. We get CH3, CCH3, O, CH2, CH2, O. You will get this ketol. What do you get? Ketol. You will get cyclic ketol. Ketone, when react with the ethylene glycol, the product is called what? Ethylene glycol ketol. Ketol. Okay. Which of the following product is formed when an aldehyde react with an amine in acidic medium? That's what we discussed. For example, aldehyde. Aldehyde is what? CHO. And amine. Amine means RNH2, which contain NH2 group. We studied aldehyde and ketone, how it behave with the ammonia derivative. Just O and this H2 cut. You will get RCH double bond NR. This is called a Schiff's base. What we call? Schiff's base. So my dear, aldehydes when aldehydes when react with the amines, the product, the addition product, what we call Schiff's base. The oxidation of toluene to benzaldehyde by chromyl chloride is called Itard reaction, right? Itard. What is chromyl chloride? CrO2Cl2. Toluene we can convert it to benzaldehyde by treating chromyl chloride is called what? Itard reaction. Aldehyde other than formaldehyde when react. We studied that theory like this one in alcohol chapter. Grignard reagent when you treated with methanol. What is methanol is also called? Methanol is also called what? Formaldehyde. Formaldehyde you get always primary alcohol. Any Grignard reagent when you treated with other aldehydes. Other aldehydes mean except methanol you will get secondary alcohol. Any Grignard reagent when you treated with any ketone you will get always tertiary alcohol. We already studied in alcohol chapter. So here aldehyde other than formaldehyde when react with the Grignard reagent to give an addition product, which on hydrolysis give you which alcohol? Secondary alcohol. You will get secondary alcohol. Which of the following will not give aldol condensation? My dear, in order to give aldol condensation, alpha hydrogen should be there. Which do not give aldol condensation mean no alpha hydrogen. Where there is no alpha hydrogen, you can say benzaldehyde. Check it all the remaining option, okay. You see benzaldehyde is this one, right? Benzaldehyde is this one, which is the alpha carbon. Aldehyde connected carbon is alpha. See, this not contain any hydrogen. So it do not contain alpha hydrogen, so it cannot undergo aldol condensation, because in order to undergo aldol condensation, alpha hydrogen should be there. Okay. Benzoyl chloride. What is benzoyl chloride? Benzene with COCl. Benzoyl chloride on reaction with the hydrogen and palladium and barium sulfate. Which is this reaction? Our Rosenmund reduction. What is Rosenmund? One H and Cl, cut it. You can make it as benzene with the what? COH. Benzaldehyde. You will get benzaldehyde. Okay. Benzoyl chloride on reaction with the hydrogen in palladium and barium sulfate will give you what? Benzaldehyde. Our Rosenmund reduction. What is a test to differentiate between pentan 2-on and pentan 3-on? You know, pentan 2-on we can write like this, right? This is the structure of pentan 2-on and this is the structure of pentan 3-on. Ready? Which test can be used to distinguish between them? I will go with the iodoform test because iodoform test is given by the aldehydes and ketone which contain this group. See, this group is there in pentan 2-on, not there in pentan 3-on. You know, iodoform color is yellow color. So, this will give yellow color, this won't give yellow color. So, I will go with which one? Iodoform test. Let's go with iodoform test. Which of the following does not undergo Cannizzaro? Does not undergo Cannizzaro means they contain alpha hydrogen. They contain alpha hydrogen. Benzaldehyde, no alpha hydrogen. 2-methyl propanol, paramethoxy benzaldehyde, 2,2-dimethyl propanol. I'm just trying. You try the structure, okay. The condition is what? Alpha hydrogen does not undergo Cannizzaro means alpha hydrogen should be there. So, Cannizzaro, you know, Cannizzaro reaction mean no alpha hydrogen. No alpha hydrogen mean it can undergo Cannizzaro reaction. Here they're asking they do not undergo means they contain what? Alpha hydrogen. Okay. So let me try B, C. Okay. Anyway, benzaldehyde do not contain alpha hydrogen. Cut it. B, C and B and D. Let us try. What is B? 2-methyl propanol. 2-methyl propanol. Okay. Check it all. Is it contain alpha hydrogen? Yes. See, this is the aldehyde. This is the alpha carbon. Yes, it contain alpha hydrogen. If it contain alpha hydrogen, they do not undergo Cannizzaro. So B can be. What about D? 2,2-dimethyl propanol. This is propanol. 2,2-dimethyl. Yes. See on this carbon, no alpha hydrogen. Okay. So remember all finally. In order to undergo aldol condensation, alpha hydrogen should be there. In order to undergo Cannizzaro reaction, alpha hydrogen should not be there. So here they are asking which do not undergo Cannizzaro means they contain alpha hydrogen. That is option B. Which among the following is most reactive towards nucleophilic addition again? See, this all are same carbon number, only difference fluorine, chlorine, bromine, iodine. I told you that electron withdrawing group will increase the reactivity. Which is the most withdrawing group? Fluorine. So let's go with option A. More the strong withdrawing group, easily it can undergo nucleophilic addition. The IUPAC name of this compound. What is this compound? CH3, CO, CH on which CH3 and CH3. What is the IUPAC name of this compound? Ketone is the main group here. So 1, 2, 3, 4. So 3-methyl butan 2-on. 3-methyl 2-butanone. Ready? 3-methyl butan 2-on. What is the IUPAC name of ethyl isopropyl ketone? What is ethyl? CH3, CH2. What is isopropyl? One CH connected to 2 CH3 is called isopropyl on a ketone. Ready? This is the compound. So how to number it? Ketone is in the middle. So let me start 1, 2, 3, 4, 5. 2-methyl pentan 3-on. 2-methyl penta 3-on. Let's go with option B. 2-methyl penta 3-on. Ready? The catalyst used in Rosenmund reduction. What is the catalyst in Rosenmund reduction? Palladium and barium sulfate. Acetone react with the iodine. What is acetone? CH3, CO, CH3. Remember this name, okay? Acetone is nothing but propanol. Acetone reacting with the iodine to form iodoform. So iodine, if it want to give NaOH also should be there. Heat. It's giving iodoform in the presence of. Okay, that's they're asking. Okay. In order to give iodoform test along with iodine, what should be there? NaOH should be there. Aldehydes and ketone are distinguished by which of the following tests? Aldehyde and ketone. Lucas test, you know, it is for alcohol, not that. Tolerance test. Yes, tolerance test is given by only aldehyde. It is not given by ketone. So that is the distinction test. Okay, question. What is the product D in the last product they are asking? Let us start. Acid is given. CH3COOH is given. Ethanoic acid. You know, ethanoic acid treated with a thionyl chloride. What happened? Acid treated with a thionyl chloride. OH remove, put chlorine. It become acid chloride. It become acetyl chloride. This on reaction with the benzene in presence of anhydrous AlCl3. That is our Friedel-Crafts acylation. So this group, put it on benzene ring. You will get benzene with the COCH3. You are getting acetophenone. Acetophenone, when react with the hydrogen cyanide, it undergo nucleophilic addition. How nucleophile add? H plus is there, Cn is there. You know, nucleophile will attack on carbon, O become O minus. To the O minus, this H plus will attack. You will get benzene with C, CH3, Cn and OH. Cyanohydrin. You know, any aldehyde or ketone react with the hydrogen cyanide. What is the product is called cyanohydrin. Note over, it's on HOH. HOH is nothing but hydrolysis. You know, cyanide on hydrolysis, it will give you what? Carboxylic acid. So we can write that benzene with COH, COOH and CH3. This is the compound D, where it is benzene, carbon, one CH3, one COH and one OH, right? That's option D. So once again, all of you, acid when react with the thionyl chloride or PCl3 or PCl5, it will give you what? Acid chloride. Acid chloride when react with the benzene in anhydrous AlCl3, Friedel-Crafts acylation, we are getting acetophenone. Ketone when react with the HCN, the product is called cyanohydrin. Cyanide on hydrolysis will give you what? Carboxylic acid. Product correct, right? Okay. No problem. Okay, fine. Next one. Which of the following reaction will not result in the formation of carbon-carbon bond? In through which reaction carbon-carbon bond is not forming? Good question. Friedel-Crafts acylation. Friedel-Crafts acylation. You just check it. This is Friedel-Crafts acylation. Here you see this carbon and this carbon is making a bond, right? That's a bond is there. Woods reaction, of course, Woods reaction means two alkyl groups are joining. Carbon-carbon bond is there. Cannizzaro reaction, yes. Cannizzaro reaction and Reamer-Tiemann reaction. Reamer-Tiemann we already studied in alcohol chapter. Which one? Phenol to salicyl aldehyde. There is a carbon-carbon bond. Cannizzaro. Cannizzaro reaction means what, my dear? We discussed now one example. Benzaldehyde react with the benzaldehyde in presence of a concentrated base. What happened? One compound convert to its corresponding alcohol and the other compound convert into corresponding carboxylic acid, but the potassium comes here. So here is see one compound converted to some other, where there is no carbon-carbon bond formation. So remember, in Cannizzaro reaction there is no carbon-carbon bond formation. In the following sequence of reaction, what is the final product is Z? What is this? Ethine when react with the mercury. Mercury means addition of water in presence of what? HgSO4. You know water contain two ion, H plus and OH minus. Since it is a symmetrical compound, add H plus to one carbon, OH to one carbon. You will get CH, OH, double bond, CH2, enol. This enol undergo which isomerism? Tautomerism. So what happened? This hydrogen shift to this. Overall you will get CHO and CH2, CH3. What is this? CH3, CHO, what we call? Ethanol. So product is what? Ethanol. Not over, not over. Sorry, not over. This is Hexa and this compound they are treating with the what? Methyl magnesium. Okay. So this one they are treating with the methyl magnesium halide with what? Hydrolysis. Already told you what happened. What happened? Grignard reagent when you add to an aldehyde or ketone, very simple. Take the alkyl group from the Grignard reagent, put it on this carbon and O become OH. So we will get CH3. Then this CH3 and this and this O become OH and this CH3. It become propan-2-ol. Propan-2-ol when undergo oxidation. We know secondary alcohol on oxidation, what we get, my dear? You will get a ketone. What is this? Propan-2-on or propanol. So to an alkyne, when you add a water with a mercuric sulfate, you will get enol. Enol undergo tautomerism. You will get aldehyde. Aldehyde, we already studied, my dear. Any Grignard reagent, when you treat it with other aldehydes, which means except methanol, you will get secondary alcohol. Secondary alcohol on oxidation, you will get a ketone. Ready? Which of the following does not answer iodoform test? In order to give iodoform test, if it is an alcohol, it should contain this group. If it is an aldehyde or ketone, it should contain this group. Which do not respond. N-butyl alcohol. Let me just draw the shape of this one. N-butyl alcohol means this is N-butyl alcohol. It do not contain that CH3CHOH group, right? Let's go with option A. Sec-butyl. What is sec-butyl, you know? Sec-butyl means this is the one called the sec-butyl alcohol. See, it contains CH3CHOH group, so it will give. What is acetophenone? Acetophenone means benzene with the COCH3C. It contains that group. What is acetaldehyde? Acetaldehyde is CH3CHO. See, that contains that group. So N-butyl alcohol do not contain that particular group, so it do not give. An organic compound of molecular formula C3H6O did not give silver mirror test. You know, silver mirror test means our tolerance test, right? It does not respond to tolerance test, means it's a ketone. Okay, an organic compound of molecular formula. This is a ketone, very sure, because it do not give silver mirror test with the tolerance reagent, but it give an oxime with a hydroxylamine. What is hydroxylamine? NH2OH. You know, hydroxylamine reacting with the aldehydes and ketone. Already said there. They said that they do not give tolerance. So that means it's a ketone. Okay, what it can be? It should be a ketone. Where is a ketone? That is option B. That's it. Very simple. So dear all, it react with the hydroxylamine means, you know, hydroxylamine when react with an aldehyde or ketone, we get oxide. So it react with the hydroxylamine mean it can be an aldehyde or it can be a ketone. But it do not give with the tolerance test mean it's not an aldehyde, it's a ketone. Where is a ketone? That is option B. Propanol on treatment with the dilute. Propanol. What is propanol? CH3, CH2, CHO. Propanol on treatment with the dilute sodium hydroxide. Dear all, dilute NaOH means what? This is an aldehyde with alpha hydrogen. This is dilute base. This is our aldol condensation. Aldol condensation. What is aldol condensation? One aldehyde react with its own. Means the same one another aldehyde. Do you remember one shortcut method we studied how to write the aldol condensation product? From the second compound, take one alpha hydrogen, give to this oxygen and connect these two carbon. Finish. You will get CH3, CH2, CHOH. Now this carbon CH on which one CH3 is there, one CHO is there. This is the product. Yeah. Where is this product identified? CH3, CH2, CHOH. Not option A or option B. CH3, CH2, CHOH, CH3, CHO. Yes, option C is the correct answer. So how we understand it's an aldol condensation? Base is dilute and the reactant contain alpha hydrogen. So study all of you aldol condensation properly. Aldehydes that do not undergo aldol condensation. Do not undergo aldol condensation mean no alpha hydrogen in the compound. Propanol. Propanol is CH3, CH2, CHO. See, it contain alpha hydrogen. So one can be. Trichloroethanol. What is trichloroethanol? CCl3CHO. Trichloroethanol. Yes, this is the alpha carbon. No alpha hydrogen. No alpha hydrogen. So second can be. 2-phenyl ethanol. Ethanol means 2 carbon and second position aldehyde. 2-phenyl ethanol. This is the alpha carbon. It contain alpha hydrogen. Not. Ethanol. What is ethanol? CH3CHO. Yes, it contain alpha hydrogen. Benzaldehyde. Already we know it do not contain alpha hydrogen. So 1, 2, 5. 1, 2, 5 is not there. Question: aldehyde that do not undergo aldol condensation. Do not undergo aldol condensation means no alpha hydrogen. Benzaldehyde also no alpha hydrogen. So 1, 2, 5 should comes. Okay, my dear, I'm just correcting here. 1 to 5. Just to cross check it whether there is a mistake or not question. See, in order to give aldol condensation, alpha hydrogen should be there. So, do not respond aldol condensation means aldehyde that do not undergo aldol condensation means there should not be any alpha hydrogen. Alpha hydrogen not present in. So, this no alpha hydrogen, right? Sorry for that one. No alpha hydrogen, right? This one contain alpha hydrogen. Okay, not possible. This one do not contain alpha hydrogen, correct? And this one do not contain alpha hydrogen. This one contain benzaldehyde do not contain. 2 and 5. Yeah. 2 and 5. Yes, option B is sorry. So, in order to do not undergo aldol condensation means what? No alpha hydrogen. This one contain alpha hydrogen, right? Sorry, this one contain alpha hydrogen, this one alpha hydrogen, this one hydrogen. These two do not contain alpha hydrogen, right? Next. Which of the following compound will undergo Cannizzaro? Undergo Cannizzaro means no alpha hydrogen. Which one undergo aldol? This is what C. C is what? Benzaldehyde. Here all benzaldehyde do not contain alpha hydrogen. This is the alpha carbon. C, no alpha hydrogen. So, no alpha hydrogen means and undergo Cannizzaro. Match the following. Clemmensen reduction. What is Clemmensen reduction? Zinc amalgam and HCl. Rosenmund reduction. Hydrogen with the palladium and barium sulfate. That's enough, I think. A2B3. A2B3 where it is? A2B3C. Anyway, iodoform test mean iodine and NaOH, right? C with the C, right? C with the fourth one, okay. And Cannizzaro reaction mean concentrated base should be there. So, D with the first one, correct. And the product X in the following reaction is, what is this? Dear, this is an aldehyde, this is an aldehyde, right? And base is NaOH. Whether it can undergo Cannizzaro reaction or aldol condensation. See, CHO, right? There is no alpha hydrogen here. While seeing the product is very clear that it undergo Cannizzaro reaction. Cannizzaro reaction, what happened? One aldehyde become corresponding alcohol. The other side become its salt of acid. Sodium is the metal here. So, COONA. Where is this? COONA and CH2OH. COONA and CH2OH. That's it. It's Cannizzaro reaction. So, one aldehyde become corresponding. Simple. One CHO you made into CH2OH. Other CHO made into COONA. If it is NaOH, Na. If it is KOH, COOK. That's it. In a set of the given reaction, acetic acid yield a product C. What is the product C? Let's find. First reaction, acetic acid when react with the PCl5. Acid when react with the PCl5, what happened to the OH? OH become Cl. This on reactant with the benzene and anhydrous, Friedel-Crafts acylation. Put this group, it is on benzene. So, benzene, you will get benzene with the COCH3. This on treated with the Grignard. Again, Grignard. What is Grignard? Grignard Mg plus the alkyl group. You know, what is alkyl group? C2H5. Put the alkyl group on this carbonyl carbon. So, C2H5 come to this carbon and O become OH. Done. So, benzene with CCH3 and OH to this who will attack? C2H5. That's it. Where is this product? CH3, C, C2H5, OH and C6H5. Option D will be the answer. Which of the following will not undergo HVZ? In order to undergo HVZ, Hell-Volhard-Zelinsky reaction, the carboxylic acid must contain alpha hydrogen. So, do not undergo alpha hydrogen means, do not undergo HVZ reaction mean no alpha hydrogen in the compound. Propanoic acid means, you know, this one, yes, it contain alpha hydrogen. So, not that. Ethanoic acid is this one, it contain alpha hydrogen. 2-methyl propanoic acid, 2-methyl propanoic acid. Yes, it also contain alpha hydrogen. 2,2-dimethyl propanoic acid. See all? 2,2-dimethyl propanoic acid. See, this is the alpha carbon, no alpha hydrogen. So, option D. Which of the following cannot reduce filling solution? Remember, filling solution is given by only aliphatic aldehydes. So aliphatic aldehydes, right? So formaldehyde is aliphatic, acetaldehyde is aliphatic, acetic acid is there. See, formic acid is what? HCOOH, right? Acetic acid is CH3COH, right? And formaldehyde is HCHO and acetaldehyde is CH3CHO. Remember all? Formaldehyde, so the fillings test is given by only aliphatic aldehydes, okay? So this is an aliphatic aldehyde. This aliphatic means normal chains. Aliphatic, both are acid. But have you noticed in formic acid there is an aldehyde group. In formic acid there is a HCHO group or CHO group. So this is what a purely a carboxylic acid. So B is a carboxylic acid. So why not A? A is also a carboxylic acid but they contain an aldehyde group. So it can give the test. Option B is the answer. Which of the following acid do not form anhydride? Do not form anhydride. We discussed like this one. Carboxylic acid when react with another carboxylic acid along with acid or heat or P2O5 and heat, it dehydrate means water eliminate, you will get acid anhydride that we studied. So which one, acid anhydride means general formula we know RCOOCOR. I will go with the option, all are acid here, I will go with option A. What is formic acid? HCOOH. See, even HCOOH undergo reaction with one more HCOOH. Even if you remove water, will you get this formula? No, where you get alkyl group? There is no alkyl group in this acid, right? So formic acid cannot undergo or cannot give which one? Anhydride. Chromic acid, okay? Acid. Next. Methyl ketones are usually characterized through. What is meant by methyl ketone? Methyl is this, ketone is this. So methyl ketone can give which test? Iodoform test. So no, the aldehyde or ketone, they contain CH3CO group. That is called methyl ketone. That will give you iodoform test. HVZ reaction is used to prepare. During HVZ reaction, what's happening? We will take one hydrogen from the alpha position. We will place one halogen on that alpha carbon. So it will give you alpha halo carboxylic acid. Alpha halo acid. My dear, for example, this is the acid. Suppose you are treating bromine with the red phosphorus followed by hydrolysis. What to do in HVZ reaction? Take one alpha hydrogen, put that halogen on that. So you will get CH2Br and COOH. That is called alpha halo acid. Okay, alpha halo acid. An alkene C7H14. Okay, C7H14 is an alkene. Ready? It undergo reductive ozonolysis. Yes, it undergo ozonolysis. Gives an aldehyde with the formula C3H6O and a ketone also. What is the ketone formula? Very simple, dear all. Very simple. Very simple. Total how many carbon in this alkene? 7 carbon. Among that, 3 carbon goes to aldehyde. So where is the remaining 4 carbon? 4 carbon will be in a ketone. What is 4 carbon contained ketone here? It can be 2-butanone, right? Option A, 2-butanone. Is it correct or not? So 7 carbon total in the alkene. So if let me just try that compound. Okay, what it can be? C3H6. Okay, CH3. CH2, CH, double bond, C, CH3, CH2, CH. This will be the compound. Because 3 carbon this side, when you know how to make the breaking, right? Cut the double bond, 1 oxygen left, 1 oxygen right. This is the aldehyde, this is the ketone, CH3CO, CH2, CH3. See, aldehyde contain 3 carbon and the ketone contain total 4 carbon. That is what 2-butanone. Let's start. Benzaldehyde can be prepared by the hydrolysis of which compound? Benzaldehyde by the hydrolysis of which compound? I will go with the benzyl chloride. Do you remember? First we will treat toluene with which one? Chlorine in presence of light. What actually we said in class is 1 H remove, 1 chlorine. That's a side chain chlorination. You will get CH2Cl. This is called benzyl chloride. It's again react with the chlorine in presence of light. You will get benzyl chloride. This benzyl chloride on hydrolysis, you will get benzaldehyde. So what is the compound? Benzyl chloride on hydrolysis give you benzaldehyde. Which of the following acid has the smallest dissociation constant? Dissociation constant is called Ka. Ka value directly proportional to acidity we studied. Dissociation constant is what? Ka. Ka value increases mean acidity increases. So they were asking you smallest Ka value mean which is the least acidic they are asking. Least acidic is which one? See here fluorine is there on this carbon. Fluorine is a withdrawing group. You know withdrawing group make more acidity. Here also fluorine is there but little far away. Anyway they are very strong. Withdrawing group make more acidity. Here bromine is far away. Bromine is very close. So A and B are highly acidic because fluorine is there. Fluorine is more withdrawing group, make more acidity. Your answer is either C or D, which is weakest acid. I will go with option C because here bromine is far away from acid. Here bromine is close to acid. So here its withdrawing power will be more. Here withdrawing power is less. So C is the answer. The most suitable reagent for the conversion. What is this? This is a primary alcohol to aldehyde, which is the best reagent to convert a primary alcohol to aldehyde, PCC, pyridinium chlorochromate. Iodoform test is not given by, yes my dear, iodoform test is not given by, let me try, 2-pentanone, 2-pentanone mean, this is the compound. Yes, it contains that CH3CO group, so it will give. Ethanol, what is ethanol? CH3CHOH. Yes, it contains that group. Ethanol means CH3CHO. Yes, it contains that group. But 3-pentanone you see CH3CH2, CO, CH2, CH3. See, it do not contain particular group. So 3-pentanone cannot give, which test iodoform test. The product formed in aldol condensation is, they are all aldol, remember all. Aldol, one another name is called beta hydroxy aldehydes or ketones. Because in aldol, what do you mean by aldol? What do you mean by aldol? Aldol means it contains aldehyde and alcohol. You try with the compound, okay, you will get like this one. Aldehyde, you will get it. You check any one of the aldol reaction we studied. Where aldehyde, I think we already discussed that. Aldehyde is there. Aldehyde connected carbon is called alpha. You check it all of you. The beta carbon contain the hydroxy group. Check any of the aldol product. So this is called beta hydroxy aldehyde or beta hydroxy ketone. Option this second one, a beta hydroxy aldehyde. Consider the following reaction. What is the compound C? Okay, I am trying. First reaction, CH3Br reacting with Mg. What happened when a haloalkane react with Mg? You will get Grignard reagent CH3MgBr. This on treated with HCHO. We already discussed, my dear. Any Grignard reagent, when you treated with the methanol or formaldehyde, always you will get primary alcohol. So one carbon here, you will get 2 carbon contain alcohol, that is ethanol. Ethanol, okay, that is followed by hydrolysis, you will get finally what? Ethanol. So what is CH3CH2OH? That is ethyl alcohol or ethanol. Benzaldehyde and acetaldehyde can be distinguished by, you know, this is benzaldehyde and this is what? Acetaldehyde. Benzaldehyde and acetaldehyde can be distinguished by, can we go with the iodoform test? Yes, because iodoform test is given by this one, it do not contain that CH3CO group. Failing solution is, what is failing solution A and failing solution B? Tell me, my dear students, those who study the theory. Failing solution A is copper sulfate 5H2O, blue color, and the failing solution B is sodium potassium tartrate, Rochelle salt. So what is that? Copper sulfate and Rochelle salt. 3. Which can be reduced to corresponding hydrocarbon by zinc amalgam and HCl. Zinc amalgam and HCl means what? Clemmensen reduction. You know, Clemmensen reduction is happening on what? Aldehydes and ketone. Aldehydes and ketone when react with the zinc amalgam and HCl, you will get hydrocarbon. So I will go with the ketone. See, this is acid, this is amide, this is ester. You know, Clemmensen reduction is given by what? Aldehydes and ketone. So this is a ketone. Ready. The enolic form of acetone is, what is enolic form? Remember all. You know, acetone is CH3COCH3. Let me write one of the hydrogen like this. Okay, CH3COCH3, one of the hydrogen I am writing like this. What is enolic form? Remember all, enol. This hydrogen shifting to this carbon. So this hydrogen reached here. So what is the product? CH3COH double bond CH2. Check it. This contain ene and ol. This is called the enolic form. In this enolic form, how many sigma bond, pi bond and lone pair is the question. So dear all, let me just expand this compound. Okay, I am just expanding. This is what? CH3 COH double bond CH2. This is the complete form. And you know, the oxygen contain 2 lone pair. Okay, total how many sigma? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sigma, and there is only 1 pi bond and there are 2 lone pairs. What is the option? Where is the option? 9 sigma bond, 1 pi bond, 2 lone pair, option A. So this is the enolic form. Okay. Next one, ethane can be obtained from ethanol. What is ethanol? CH3CHO. Ethanol can be converted to what? Ethane, CH3CH3. What is this reaction? Aldehyde converted to hydrocarbon. That is either Clemmensen or Wolff-Kishner. What is Clemmensen? Clemmensen is there, zinc amalgam and HCl is there. What is the IUPAC name of crotonaldehyde? Dear all, crotonaldehyde is a special compound which is given in textbook. Study all of you. This is called crotonaldehyde. Crotonaldehyde, this is the compound. So aldehyde is main group. So 1, 2, 3, 4. So this is but 2 in 1 al. But 2 in 1 al. But 2 in 1 al. That is called what? Crotonaldehyde. Okay. Next, what is the IUPAC name of tartaric acid? What is tartaric acid? Some common compounds. Okay. Tartaric acid is COOH, CHOH, CHOH and then one more COH. Total 4 carbon in the chain where first and fourth are acid, second and third hydroxy. So what is the name? 2,3-dihydroxy. 2,3-dihydroxy butane 1,4-dioic acid. Let's go with option 1. Yes all? Butane 2,3-dihydroxy butane 1,4-dioic acid. Ready. Now, which of the following is the strongest acid? See, already there pKa values are given. pKa value. Remember, Ka value increases mean acidity increases, but pKa value increases mean acidity decreases. So question, strongest acid. Strongest acid mean what? Lowest pKa. Where is lowest pKa? That is first one. Which compound is most reactive toward nucleophilic addition? Most reactive mean it should be an aldehyde and less a bulky group. Which one is that? That is very simple. This ketone, ketone, ketone. This is the only one aldehyde, right? What is pH stands for, my dear? pH is phenyl, okay? So this compound is actually what? PHCOCH3. This is the compound. pH is phenyl group. So all this ketone, this is ketone, this is ketone. This is the only one aldehyde. So most reactive are aldehyde. Now, what is this final product here? What is this zinc amalgam and HCl? Zinc amalgam and HCl mean Clemmensen reduction where CO group become CH2. So, it become CH2, CH3. So, what is the product? That is compound 4 is the answer. CO group becomes CH2. That's it. Whatever the aldehyde and ketone, the CO group becomes CH2. Finish. So, answer is 4. What is this reaction? Can you identify what is this compound? You know, this is a carbon, 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 carbon. Okay. So, let me take the compound as CH3, CH2, C triple bond, CH. That is our addition of water reaction. Addition of water with what? Mercuric sulfate. Right. You know, H2O contain H plus and OH minus. So, OH come to this one. Same example we discussed in this first session. So, CH3, CH2, COH, double bond, CH2. You will get enol and it undergo tautomerism. What is tautomerism? This will shift here. You will get CH3, CH2, C double bond O, CH3. You will get it. Where is this compound? Where is this compound ketone CH3, CH2, C? Yeah, that is option 1. CH3. This is what CH3. This is what CH2. This is CO and then CH3. In the carbonyl group of aldehydes and ketone, what is carbonyl group means? CO group, right? This is called a carbonyl group. Okay, not clear. I'm just writing like this one. C double bond O. Okay. Question: what is the nature of the double bond between carbon and oxygen and type of hybridization of carbon? See, my dear, this carbon oxygen means 1 sigma 1 pi bond. What is the hybridization of this carbon? We discussed that in carbonyl compound the hybridization of the carbon is what? sp. This is trigonal planar shape, sp2. sp2 is the hybridization of the carbon. So what is the answer? The carbonyl group, aldehyde and ketone. What is the nature of double bond between carbon and oxygen? 1 sigma 1 pi. Okay, so 1 sigma and 1 pi and sp2 hybridization. Let's go with option C. Okay, and we study this one. In carbonyl compound, when a nucleophile attack on the carbonyl, so then the compound becomes like this. Now it becomes tetrahedral shape where the hybridization is sp3. Now they are asking only about carbonyl compound. By dash, ketone can be prepared in one step. How can you prepare ketone in one step? Yes, there is an option, oxidation of secondary. Yes, oxidation of secondary alcohol give you a ketone. Why I'm going fast means, you know, there's a video lecture, so you can stop the video and see that we can analyze faster, okay? Which of the following is the most suitable catalyst for the esterification of acetic acid and ethanol? See, when an acid react with the alcohol, we get an ester, right? We get an ester. This is happen in presence of a mineral acid. Okay, esterification is happen in presence of which one? A acid catalyst. Well, for example, yeah, HCl gas, HCl, H2SO4 acids. Benzoic acid react with, what is benzoic acid? Benzene with COOH is called benzoic acid. Benzoic acid react with the phosphorus pentachloride, PCl5. What happened? The OH becomes Cl, that's it. What is this compound is called? Benzoyl chloride. Benzoyl chloride. Okay. Acid when react with the PCl5 or PCl3 or SOCl2, we get acid chloride. Next, other than ethanoyl chloride, what are the byproduct formed when ethanoic acid react with the PCl3? Ethanoic acid when react with the PCl3, we already studied this reaction in our haloalkane chapter, where there is an alcohol, that's it. Acid when react with the PCl3, the OH becomes what? OH becomes Cl and this become what? H3PO3. Option A, H3PO3. Which aldehyde will give Cannizzaro reaction? If it giving Cannizzaro reaction mean no alpha hydrogen. Where there is no alpha hydrogen, option C. Many times we discuss CHO, this is the alpha carbon, no alpha hydrogen. Which will give Cannizzaro, right? Yeah, okay, fine. Which of the following ketone has the common term acetone? What is acetone? Acetone is CH3COCH3, that is our propanone. But that is not the right. Which of the following ketone has the common name acetone? What is acetone? Another name. Dimethyl ketone. Dimethyl ketone. Yes, option A. Dimethyl ketone also can be said. What is diisopropyl ketone? IUPAC. What is isopropyl? This group is called isopropyl. Diisopropyl mean, yeah, one more is there. In between there is a ketone. This is the compound called diisopropyl ketone. What is its IUPAC name? 1, 2, 3, 4, 5. So 2,4-dimethyl. Where is that? 2,4-dimethyl B. 2,4-dimethyl pentan 3 on. Ready. That is it. That is the 100 MCQs we completed for the chapter Aldehyde, Ketones and Carboxylic Acid.